Introducing helical motion. Helical motion redefines elevators. It requires no cables nor counterweights. It is fail-safe. The design eliminates the dead drop. Helical motion is, in a sense, a giant nut propelling itself through a threaded tube. The helical rail inside the elevator shaft is the thread that always supports the elevator car. A nut with rollers that rides on those threads turns inside that shaft. Varying the pitch slightly on one side of the helix introduces a slight curve. The elevator car can traverse in a curvilinear path. The shape of the elevator car is tapered towards the top to accommodate curves in the path. With two elevator shafts and multiple cars, it is possible to shunt cars between shafts. With shunting, fewer elevator shafts are needed to support a given traffic load. Configurations can change dynamically. Passengers can be loaded on cars continuously during rush hour, with one shaft dedicated to upward movement, the other dedicated to downward movement. How about a scenic elevator on the outside of a building that also wraps around, providing panoramic views? Would you want to ride up to the top of your favorite tower and look around the city? How about an elevator that is installed almost from day one? An elevator that reduces reliance on cranes. One that grows as construction goes on, transports all the load you need, is not limited by size, nor weight, nor height. Can you imagine lifting a concrete truck to where it is needed instead of pumping concrete from far away? Here's how it works. The elevator shaft has a rail arranged in a helical or spiral pattern, like a slinky. This rail serves as a thread. The elevator car is like a nut inside the threaded shaft. This nut has two parts. The propeller, which has rollers arranged in a matching helical pattern and rides on the rails in the shaft. And the load platform, which rides on the propeller. A motor under the platform drives the propeller. The load platform does not turn as it indexes itself against the opening in the helix. The load platform carries the passengers and freight. This is a simple, elegant design. It uses no cables, no counterweights, no magnetic levitation, no complicated brakes. It has few moving parts. It is fail-safe. The helical rail supports the capsule throughout, eliminating the dead drop. Notice that the propeller turns on the horizontal plane, causing the elevator car to move in the vertical plane. The movement of the car is a side effect of the horizontal rotation of the propeller. This orthogonal movement has a few unique properties. First, there is no way for the elevator car to move without a push from a motor or a manual crank in an emergency. It cannot roll back or down accidentally. Second, there is very little momentum. Vertical travel halts as soon as the motor stops. There is very little need for braking. And third, the torque requirement from the motor is high and constant throughout. Elisha Otis's cable-based safety elevator made high-rise buildings possible. It is a marvel of engineering. In the 170 years since that invention, there have been a few innovative ideas, but none to seriously challenge the dominance of the cable-based elevator. The challenger has arrived. Helical motion.